What is up, ladies and gentlemen? Today we're about to draw some trails. Also, I'm back. I was not burned out, the hype didn't die, and actually I haven't moved to paid work as well. Doing it completely unpaid. But the thing is, I was building a badass geometry nodes course, which is now ready. I'm gonna tell you about this later. But now trails. Now this is the effect I wanted to do for a long time. Well, 2 years actually, since the start of the course. So first, to make any sorts of trails, what you need is something to put those trails on. So let's import a little character here that is in FBX format from Mixamo. Put a little swing down, and this is actually the same animation that is in the start of the intro, so we can compare very well and see how we can improve. Let's use this cube here because it's a bit easier to understand what we're about to do. So if you want to draw a trail to this cube, obviously the cube needs to move. So I'm going to hide this armature and the joints and everything, and just use the cube for a moment. I'm gonna go to the top view and let's animate this. So with the top-notch animation skill here, let's add a keyframe, and let's go to the frame 90 and let's add another keyframe like that. And now the cube moves from left to the right. It is super slow. Let's make it much faster. Now, if you want to leave a trail, this would look something like that. First, we have no trails, then we move to the frame 31, and then, for example, we have a trail like that, which becomes longer and longer as the cube moves. So let's try to make something like that in geometry nodes. So I'm going to add an object to add trails on. I'm going to call this object trails, and then I'm going to add a new set of geometry nodes on it like that. Geometry nodes, of course, what else? So let's remove the internal geometry of this object, and then it's just an empty dummy object that we're gonna create all the geometry in geometry nodes. Let's create a trail system, and for that we need first access to the object we wanna create the trails from, which is gonna be our little cube, just for a moment before we get to the character, before we get to the cool stuff. So I'm gonna drag in the cube, and now we can output the cube from here, but we're not interested in it being, here. We're actually interested in getting the exact surface of this cube object. So we're going to the relative mode, which scales and moves the cube exactly so that in our geometry node system, it is located where it is in the world space. So if I now hide the cube, you can see the cube didn't disappear because it gets output from the trails object. So I'm going to pin the nodes so that I don't lose them, and enable the cube again. Now I have two clipping on top of each other. Well, now we have access to the surface, but we need to define where we want the trails to start from. A good way to do this is just to use some points. So what we're going to do is take a distribute, how it's pronounced, I don't know. We're going to distribute points on faces, which adds a couple points. So that is fine for now. And let's say we want to start a trail, from this point. So as you can see, the cube moves as we play the animation, and we want each point to draw a trail. And what this means in practice is, we have one point here, let's say this point right here, and then on the next frame, we want to have both of those points, and then on the next frame again, we want to have a third point as well. And I'm going to enable onion skinning so we can see the previews, and as we move here, we can just continue adding those points. So essentially each frame, the point should leave a copy of itself behind. So let's do this. On each frame, let's leave a copy of itself behind. And for that, I'm going to use the simulation zone, which is a zone in geometry nodes that repeats everything that is inside of it every frame. So for example, if we just take a single point as an example, and the output that we see here, well, you can see the point is in the center here, so nothing really happens. But if you, for example, add a set position node and we move it up 1 millimeter each frame, then you can see the point starts to move up slowly because the geometry is first taken in, and then every frame, this thing here is ran. And this means the point moves up. Now, we don't need to do any transformations like that. What we need to do is instead, on each frame, leave a copy of ourselves behind. And we can do it very easily with the join geometry node. So what now happens is, watch if I play this, we'll leave a trail like that. And we leave it behind because on every frame, we re-repeat what is inside here. So on the first frame, we just take in a bunch of points and join it with empty geometry and pass on. Then on the next frame, what happens is we already have some points coming in from here, and then we add some new points. And then on the next frame, we have already more points coming in from here, but we continue adding points. So on each frame, we just add the previous points together with the new one, and this creates a trail. But obviously it is a bunch of points, but we need some trails, some paths that you saw also in the intro. If you hear the word path, this means curves. So let's add a node called points to curves. And obviously the current result is very bad, because if you play the animation, it doesn't look nearly as trails. So what instead needs to happen is we need to make use of this curve group ID here. And we need to group our points. So as you can see currently, without these points to curves, we have clear paths. But the node doesn't really know that we have those clear paths here. Instead, it just connects the points based on their index, and the index of those points is probably really messed up, or like messed up for our use case. So how the index looks, an index is just the internal order of elements in Blender, is, for example, this point is 170, 180. So this one, for example, would be connected to 171. So where is 171? It is here. So we will have a link like that. And this doesn't work for us. Instead, we need to create some data that is common for the trails. So all those points should have a common value. Then all those points should have a common value, and all those. So we have like a grouping of trails. And for that, what we can do is go to the start, where we can see these are only the original points with the original indices of those points. As you can see, these are all unique, which is how indices work. They're all unique. What we can do is store that index as an attribute. And this might not make sense right now, but I'm going to show you why it makes sense. So I'm going to add a new store named attribute node. I'm going to add an index, put it here, and call this original index. And now I'm going to plug this here and remove the other connection. So essentially we have the exact same system as we had before, but only the difference is that we just have the store named attribute. Now, by itself, it doesn't fix anything magically. Instead, what it does is it gives us data that we can use to fix things magically. So if you now take the named attribute node and you preview, well, you don't see the attribute. And that's because if you see this purple line down here, this means the simulation bake. And as you can see, it is dashed, which means that here you have done something that has updated the state, but the simulation is not updated for it. So what we need to do is to go to the first frame and play again. And then the simulation zone updates itself. And now we can see the original index attribute. So if you now preview it, you can see the original index, well, on those points is like that. And then if you preview on the copied points, well, because they are copies, obviously they just have the same attribute. So now we got 8 on all of this trail, and we got 6 here, and we got 4 here. So these are essentially perfect to group our trails together. Let's do this in the points to curves node. Let's plug it here, and let's tame it a little bit by plugging it here. Boom, and we got the trails. But there is an issue, and this is why I wanted to start with a cube, and this is very important. It currently works well enough, because the cube doesn't change its shape at all. And it would work with this robot here as well. Because the robot is not biological, so it doesn't like will in any ways, it just stays sharp like that. It doesn't have any deforming geometry. But if you have deforming geometry, then this distribute points on faces starts to get a little bit weird. I'm going to show you what I mean by that. So I'm going to hide the robot again, and take the cube, go to the first frame, and I'm going to add some more animation. So I'm going to go to the first frame, add a scaling keyframe, last frame, add a scaling keyframe, and to the center, I'm also going to add a scaling keyframe, and I'm going to scale on the y-axis pretty big. So now we have something like that. And as you can see, the paths don't look very good anymore. And that is because if you look at the distribute points on faces output, and we go to the first frame, and we go frame by frame, you can see as the cube becomes larger, it has more points added onto it, which is probably even more visible when you have like more. So you can see new points appear, and those new points have different indices because, as you remember, indices have to be unique. So what happens is, let's say point, this is point 3 here. as you can see. And now if I continue playing this, let's keep an eye on the point 3. And you can see suddenly it is 0.4 because we have added a point somewhere and now the indices get reordered, and therefore what was previously 0.4, where is it? Well, I don't really find it. Let's say, you know, 0.4 was here, so 0.4's trail was drawn, and then on the next frame suddenly 0.4 is here, so it will be like weirdly jagged. As you saw, if you played the animation, this is exactly what happened. You got those like weird, very sharp turns and jumps. So we can't use distribute points and faces. It is not reliable when you have deforming geometry. Instead, we need to build our own, which uses UV maps. What we want to do is just to create a bunch of points that you can see here. Let's say, you know, 50 points. And we want to move them onto our cube at random locations. So we need now those points to be the ones that draw the trail. And we need to place them somewhere. And we need to place them on the cube because currently all of those points are in the center, and if the cube moves, the points really don't care about it. But we need to move them onto this cube's surface location-wise somehow. A good start is just adding set position node because this allows us to move the points. So as you can see, we can move them around, we can move them up, we can move them in all sorts of directions. But we need the position to be somewhere, you know, on the surface of this cube. And for that, what we can use is a sample UV surface. So this node lets us take information based on UV coordinates, and UV coordinates are important because they are a very stable thing related to this geometry. So if there is like a UV coordinate value, you know, as you can see in the UV editor of this cube, doesn't matter how the cube moves in place, the UVs are the same. This corner on the UV map is located still here, and regardless of how the cube itself moves, I mean, on the UV map it looks the same. So the UVs are a good stable source to help place the points. So what we need to do is to first define the geometry which we want to get information from about the position, and this is our cube. And then we want to tell Blender which sort of information are we looking for, and we are looking for the position. So let's set it to a vector because the position is made of 3 components, X, Y, and Z, and not just a float, which is miserably small for a position vector. So let's plug the position here. And now we have a setup that takes from the cube the position, but we haven't yet told from which UV map and from which location. So let's go a bit forward, and don't worry, I will explain it once more once we get to the end with the system. So now we need to define the UV map of the cube. So I'm going to go to the first frame again and add a viewer to this cube so the attributes get refreshed. And we can see here a UV map. Now this probably is the UV map of this cube. As you can see, if we select the cube and go to the UV map section here, you can see there is a UV map called UV map. But we can also, for clarity, just call it cube map. And now if we go geometry nodes again, you can see there is an attribute called cube map. Now this is definitely the UV map of this cube. So let's plug it here. And now the system does so that for all points, and let's connect it to the position here, for all points, it samples the UV value 0, 0 from the UV map of the cube and gives us the position value from there. Now, if you look at the UV map of the cube, and I'm going to go to the UV editor again, well, it is pretty logical that the position 0, 0, which is at the corner here, isn't really on the cube. I mean, the only locations in the UV map that are on the cube are those islands here. So to understand how this node works, let's try to move all of our points to, for example, this location on the cube. So to understand that, and I'm going to go to the first frame actually. So let's do that location here. So to understand that, first you need to see which face it is. It is the face here. And just, you know, actually using the 3D cursor, I think we can get a pretty good understanding. Okay, this is the UV coordinate of this location here. So let's copy it over here. So let's put here 0.688 and 0.625. Now let's preview the points, and you can see, well, because we don't really know exactly where we place them, but they're pretty much here, so you can understand how it works. And if you move the UV a little bit, you can see how the points move on the surface of the cube. So this is great. Apparently it works, but we want each point to have a random position on the cube. So let's do so that we just take a random value, and for each point here, we're going to generate a random vector that has the minimum value of 0 to 1 on the first component and 0 to 1 on the second component and 0, 0 on the third component. So this gives us, random positions along the x, random positions along the y, and this is the range of the UV map from 0 to 1. So if you now plug it here, you can see, hopefully, yes, that we got a bunch of points on the surface of the cube. And what is the most important thing is that when the cube now moves, you can see we don't get more points. We still got the 50 points. They just get stretched around and close together, and nothing really happens with them, unlike with the distribute on points node. So let's add a little improvement here, one last improvement, and then we get to the character. The issue is that not all the points get moved. As you can see here, there is something left behind. And that is because, when we create a bunch of those random values for those points, some of those random values end up at, on the cube's UV map, and they get the position from the cube from there and then move there. But some of the random points also go to locations where the cube's UV map is not defined. So we get a bunch of errors and they don't really move anywhere. They just are kept in the 0, 0 position here. So let's do so that we just delete those points. So I'm going to use delete geometry, plug it here, and there is actually a very handy output here, which is valid, which means are the sample locations in this node actually on a face or not. Let's plug it here, and now you can see, well, okay, the valid ones got removed, but the problematic ones remain, so we need an inverse of that, and for that we can use a Boolean math. So let's plug it here and use the not operation. Not just inverts what was before, so it just tells the opposite of what was, essentially like politicians. Okay, so this is the not operation, and now if you go to the start and play this again, you can see no more problems and the trails work perfectly. Okay, nice. Let's go on to the character. Let's make it pop. Let's take the node system here and let's just replace the cube with the character. Okay, I'm gonna remove the cube. Thank you for your service, but we don't need you anymore. So now we need the alpha surface. Doing a nice swing here, and we are going to use this as the input of this node system, like that. Go to the first frame, play this, and you don't see anything. No need to get disappointed yet, because the issue is the cube map here, which is the UV map we are searching the locations of the surface of the alpha surface. Well, the alpha surface doesn't have any cube maps. It only has, well, a map1 UV map. So let's go to the geometry nodes trail system and let's select the map1 attribute. Again, if you don't see it for some reason, add a viewer here, go to the first frame, and I guarantee you will see it. So the map1 is now here, and if we play this, you can see, well, a disappointing, miserable failure. And that is because the map1 of this character has overlaps. So if you go to the UV editor and select the object and you look at the UVs, you can see it has overlaps, which is fine for texture work sometimes, but it is not fine in our case, because if you have a UV overlap, like for example this part here, which is this hand, and then this part here, which is the part of the body, if those two overlap in the UV space, this means that sometimes the sample UVs will get the position of the hand and sometimes the position of the body. And this creates this flickering between frames that sometimes a point 0 is at the body, sometimes it's at the hand, body, hand, and obviously it doesn't work for us. So if you want to keep this UV map, it's fine. Let's just add a new one that you only use for the point sampling. So I'm going to add a new UV map called for trails, and I'm going to just smart UV project unwrap. It can be random, it doesn't have to be a good UV map. So we go to geometry nodes again, and we select the attribute that we now use, which was for trails UV map. And we play this again, and now you can see, well, holy moly, we got some trails here. So let's take a moment to enjoy them. Okay, now let's go forward and let's make them actually good. So if you look at the intro, you can see the trails have color and they look overall very fantastic. Ours don't. So let's first add some faces to them so they can be rendered and not just be plain paths. First, I'm going to delete the cube. We don't need this. And then let's go to the no tree. And let's go to the end where we have the curves. So this region right here is where we can turn them into a mesh. It's not before, it is not, well, after there is nothing, it is right here. So this makes our choice very easy. And to add faces for a curve and to render it, we need a curve to mesh node, because curves by definition can't have faces, meshes can. So let's do a curve to mesh conversion real quick. And well, it has turned into mesh, as you can see. In here we have a curve of 35 splines, and out here we got a mesh of like vertices and edges, but 0 faces. So for that we need a profile. Let's add a curve circle and use it as a profile of the base curves. And well, obviously it's too big. So you can either scale down the radius of the profile, but this means that all of the curves will have the same size. But we don't want this to really happen. So what we want to do is to scale it down here, because here, as you can see, this is a field input, which means it can accept different values per different geometry elements, in this case for splines. So each spline can scale the profile in a different way, which adds variance, which makes things look better. So let's add like 0.01 for the scale currently. No random values yet, maybe 0.05 even. And let's play this now, and you can see, well, looks pretty good, you know, looks pretty good. It doesn't happen right now, but on weaker computers, this can bring performance issues because the profile is so high res. Because currently we already have like how many? You know, we got like a massive amount of vertices adding constantly. So let's turn it down to like 8. You don't really need a lot of resolution here. It doesn't make the end result better. And now let's see about the next part, which is making them, you know, a little bit more flowy, because currently they're like frozen in time, but it needs to be like boom. As you also look in the intro, you can see when they move, they kind of like freeze in time slowly, like this was some kind of a chemical reaction going on inside of them. So you can go to the simulation loop and build a custom inertia system that somehow moves them and takes into account the position of the previous like elements coming out from the body of this character and so on. Or we can just use the blur attribute nodes. Well, this is much easier, so let's use the blur attribute. And to know what to even do, let's see how the flow looks. As you can see, inertia is related to position, not color, not you know, any effects on here. It is related directly to the position of the curves. So let's go to when the curves still are curves, and let's add a set position nodes, put it here. And let's now add a blur attribute nodes. And well, what do we want to blur? Well, we want to blur the position. So I'm going to take the position node as well. Now the blur attribute itself doesn't, you know, do anything like that. You can't just connect it to somewhere and expect it to work. The blur attribute just mangles data. You need to do something with the data. And for that, we're going to use set position. So I'm going to take the position, set it to a vector, again, to avoid squeezing the vector position into a float, and plug it into the position. As you can see, immediately something changed, and if you want to see more of it changing, then just take the iterations count and crank it up. And as you can see, well, okay, blurring works. What blurring is just taking data from your neighbors and mixing it with your own data. This creates a blurring effect both on an image and also, in case of curves, with the position of those curves. So this works like that, but it has a couple of issues, as you can see. It has kind of this flowy motion to it, but the thing is they don't reach the hands of the character. So if I turn the blurring off, then you can see it reaches it well. If I turn it on, then it is not there anymore, for example, with 50 iterations. So we need a way to make the ends reach the hands. And for that, what we can do is use this weight input here. So what this does is it mixes between the original position and the blurred position here. So we can mix between those two effects. I think it's a bit more complicated than just mixing them, but essentially this is what it does. When the curve is close to the hands, we're going to use the weight 0. And when it is further away from the hands or from the body, then we are going to use the weight of 1. And to do this, well, it is pretty easy to just use a spline parameter and use something like that. Well, it looks like a complete mess, but if you enable the color overlay, you can see that when the trace is drawn, the curve's start is here because it's a dark value. So the spline parameter outputs 0 to 1 from the start to the end of the curve. So you can understand like percentage wise, how far are we on a curve? And as you can see, it's dark at the start and white at the end. Now this is what we can use as the weight of the blur attribute. So I'm going to just plug it here, And as you can see now, the ends connect to the ends and the surface in general. And if you play this, you can see it has, has a bit more of that zing to it. So it isn't just a rigid thing, comparison like that versus something like that. This works much better. Now, from the intro, you can see that the trails actually do end sometimes. They don't go on infinitely like we have currently. So we need to find a way to cut them off. And to cut them off, well, there are a couple of things based on which we can cut them. We can, for example, make a system that trims the curves. So for that, we can just take a trim curve node, plug it here. And what it does is it, for example, cuts it when the trails are longer than 1 meter. So it would be something like that. But this isn't very natural. For example, if I had trails around my finger right now, this would be problematic because the trail is in no way longer than 2 meters. So it would take ages for it to actually finish. So what we need to do instead is to cut it off based on the age of the trail. So how old is each trail? Well, a trail essentially doesn't have an age, but each point of the trail is emitted or created at a certain time. So first we got, point 1, 2, 3, 4, 5, 6, 7, and so on. And we can create an age system so that we go inside the simulation loop, and each frame we add 1 to the age of each point. So the points that exist get 1 added to their age each frame, so we can see how many frames the points are old. Okay, so I'm going to take an integer attribute because frames are integers. They don't have any decimal points like floats. And I'm going to call this age, and then I'm going to add a math node and, just an integer math. A normal one works as well, but, let's be precise here. And now I'm going to take an attribute, going to go to the first frame, which is called age, and do like that. Now, this is a bit of a recursive thing here, so it might be hard to wrap your head around, but essentially what it does is if it finds an age attribute on a point, it adds 1 to it and stores it as an age attribute. So on the first frame, obviously this geometry here doesn't have any age attribute, so it gets stored on it, essentially 0 plus 1. So on the first frame they get like 1, on the second frame 1 gets added to the already existing age attribute and it gets 2 and so on. So we now play this, and we go now here points to curves, and we preview the age attribute. You can see it's full white. Well, that's because we are dealing with really large numbers. So let's go to attribute text, enable it, and you can see that the age of those is like 1, 2, 3, 4, 5, 6 as it's coming out from the hand. If you go to the next frame, then you can see the age increases for each point with each frame. Perfect, and we can use it to cut off the tails. So what I'm going to do is delete that trim curve here, and instead let's just use delete geometry. So I'm going to put this here, connect the age here. Obviously, this doesn't work like that. It doesn't even understand what it has to do. So instead, we need to create the kind of condition. So let's do so that if the age is larger than 50 frames, then delete all the points that are true from this condition. So I'm going to add a compare node, put it here, make it an integer, plug it here, and if the age is larger than 50, then delete all points that respond to this condition. If you play this now, you can see, well, it does work. So the trails at a certain moment just cut off, and it looks overall a very pleasing animation. Wonderful. So now let's add colors to the trails, because as you can see, those are very plain and boring. So I'm going to go to the end of the node tree and take a set material node, put it to the end, and just add a material to those trails. And then I'm going to go to the shader editor, select the trails, and just pick the material that we had, which also adds it here. Now let's go to the rendered view, and I'm going to use Eevee just to make things a little bit more responsive and turn on the scene world and scene lights, or turn them off. And these look very boring. So we don't want to use principled BSDF, we want to use some emission, we'll make them pop nice and clean. And well, obviously you could just set a color here, but this is extremely boring. So instead what we want to do is use a gradient that in the intro's case mimics like burning or combustion. So for that we need it to be super bright at the start, and then gradually go to darker and darker colors, or like colder colors. So this makes it feel like very fiery and have like this zap to it. For that we need a color, where is it? The color ramp. So we can, for example, put like, I don't know, red here, and then we can put blue here. This is pink. And now this pink and blue, if we just connect it here, doesn't work. It actually just, as you can see, by default uses the factor 0.5. So it takes like a value from the center. So it can be either pink or it can be blue, but it isn't actually flowing along the geometry as we wish. We need to connect something here that has the value 0, let's say, at the start, and has the value 1 at the end. What can we use for it? Well, for example, the spline parameter, but I think it would be cooler to use the age attribute, because this is, like a real chemical reaction. Depending on the age of the reaction, the colors change. So let's use an attribute node here and type in here age. And now if you preview it, you can see a bunch of white stuff here. And this is perfectly fine because the values are, as you remember, age is like super large values. For example, some points are currently 230 plus frames old, which means the brightness is 234 or something, which is massive. So let's instead take a map range, and let's map this range, as the name says, to go from where it was before, from 0 to 50, now be from 0 to 1. And as you can see, well, it works. Now we can actually see the gradient. And if you connect it here to the color, you can see, wow, this works. This looks nice. Now let's just tune the gradient to actually look good. So first I want to set the early points that are near the surface to be super bright, essentially white. And where are the early points? Well, they're on this side. I don't really like that. I would like this to be more like bright and then gradually go darker here in the gradient. So I'm just going to inverse this thing. And now it works the other way around. So I'm going to make this one really bright and almost white, maybe something a little bit yellowish. And then I'm going to make this one blue. So this is like the coldest color we can get, something like that. And then in between here, I'm going to add a yellowish something near here, and then a purplish something here. So this is essentially my gradient. As you can see, the trails are ready. And you're like, well, they don't look at all like in the intro. So what's the secret? Well, the secret here is in the compositing. So what we can do now is go to the compositor, click on use nodes, and turn on the compositor, always the viewport compositor. And what you can take is a Kuwahara filter, plug it here, and with the size of 6, it does really almost nothing, but put it to 25, and you can see, ooh, okay, these are the trails we are talking about here. So the geometry just is a basis, but the real magic happens in the Kuwahara filter. I'm going to add more points. So I'm going to add 2 workspaces, and in the bottom here, geometry nodes. And let's just add like 150 points and play this again. And you can see, well, this does look pretty good. Now, the issue is that the character, we don't want to Kuwahara this character. We want to do this with the trails. And for that, we're going to use Cryptomat. So let's go to the view layer. And down here, you have Cryptomat, and enable the object-based Cryptomat. Cryptomat is for isolating objects in the compositing. So after the rendering has been done. And to do this, let's just add a Cryptomat node, put it here, and here you have a little picker. So what you can do is pick some objects like the alpha surface or the trails, and I want to pick the trails. And now if I preview the matte here, Ctrl-Shift-Click, you can see only the trails have a mask on them. And we can use this very cleverly to only use the large Kuwahara size on those parts of the image where we have the trails. So I'm going to plug the matte into the size and put the viewer back here, and you can see it's disappointing. So before it was way more beautiful. But as you can see, if we enable the filter, look at the thickness of the actual strand. And if you now connect the matte to it, it like cuts it off very sharply. So instead what we need to do is to make this Cryptomat a little bit larger, to like extend the white areas here. So I'm going to take a dilate erode node, put it here, and with the steps, just, add something to it. So like, maybe let's make like 5. So now this is thick enough, and let's connect it here. Now, I think we still don't see anything because this value by default, a mask, has 0 to 1 ranges. So the black area is 0, the white area is 1. But in the Kuwahara, we want the white area to be 25. So what you can just do is use a math node, multiply this thing with 25. And now the black areas are still 0 because 0 times 25 is 0 and 1 times 25 is 1. Now we have the correct values here, and if you preview, you can see, well, the character is pretty much intact. If you disconnect this, you can see the character is filtered, and now the character is not filtered. Now, depending on the dilator road size, you can control how much you want this to extend. I think extending this a little bit gives this cool effect that the character morphs and blends into it. And ladies and gentlemen, these are the trails. If you liked what we did here and you want to come up with such cool things yourself as well, then I have a thing exactly for you, which is the Geometry Nodes Bootcamp. In the Bootcamp, I teach you how to make 4 useful tools. For example, a better array that instances and avoids overlaps, and also a road generator, cables on curves, and so on. The course is 10 hours of lessons, and when there's a new topic, the lesson also has text recaps that explain the theory in more detail. Then there's 20 quizzes that fry you deep, and of course a comment section where you can ask for help. And if you didn't notice, a full custom streaming platform made from scratch only for this course. Can you imagine that? Yes, I went too deep, I know, but it's cool, you know. You can also try out like the first couple lessons for free so you can get a taste of it, see if it works for you. So yeah, that's what I've been up to. Go draw some trails and let me know what you think of the course. Peace.